Welcome to the presentation of the TempoGRAPHer system. We will run a scenario using the primary school graph where we will show how TempoGRAPHer can help us design a policy for reducing the spread of an infectious disease. So we will study the evolution of the graph to detect groups of students that are more active and therefore more likely to spread the disease. So first we run the graph overview to visualize the graph on various time points and get an idea of the evolution of the graph through time. So we select the primary school graph and let's say the 12th time point and the class attribute and press the view button. So here we see the graph on the 12th time point. Each node in the graph is colored based on the class a student belongs to. And also by hovering the mouse over a node, we can see the node ID. Here we see that we have 5 clusters clearly formed based on the class attribute, which is a first indication that students' interactions depend on their class. We continue with the next time point and again the class attribute to see what is going on next. Okay, so we notice a more complex view where students interact with each other regardless of their class. So we can assume that the previous time point, the 12th time point, corresponds to interactions during lessons held during the 12th hour, while the 13th time point corresponds to break time. We also want to study the students' interactions at a higher level, so we proceed with graph aggregation. We choose again the 12th time point and the class attribute and press the aggregate button. So we view the aggregate graph for the 12th time point based on the class attribute. This is a weighted graph where each node corresponds to a class. And the weight of the node is equal to the number of the students that belong to this class. And also the weight of an edge is equal to the number to this kind of edges in the original graph. Here we notice that most interactions occur between students of the same class. And let's see what happens in the 13th time point. So we notice that students of a class have more interactions with students of other classes compared to the students of the same class. So we can derive that breaks can increase the risk of a disease spread. To get further insights on the nature of the interactions between students, we use the graph exploration from here. And we will investigate their stability. First, we will study the stability between students of the same class using the skyline-based exploration. So we choose the event of stability, the class attribute, and we will choose a junior class like 1A and press explore. So the plot depicts the most important results derived from a skyline exploration with either long interval or high count. So here we report 10 results for the stable contacts between students of 1A. And next we will choose students of a senior class, let's say 5A. Here we report more results. We have 14 results and notice longer intervals of stability and higher counts. Next, we will use the interactions-based exploration, where we choose again the event of stability, the class attribute, junior class 1A, and to determine an appropriate value for K, we will choose a value close to the average count value we got from the skyline results. So we set K equal to 15 and press explore. And here we will focus on exploring intervals of stability with at least 15 interactions. So we report 14 results here for the students of 1A with periods, with stability periods of length 2 being the longest ones, like this one from 1 to 3, from 6 to 8, from 8 to 10, and from 9 to 11. Next, we will do the same for the students of the senior class 5A and the same K, and press explore. So here we have more results, 16 results compared to the students of 1A, and we report a 5 length period from 6 to 11, which is the longest one. And we can derive that older students seem to have more stable contacts compared to junior ones. As a conclusion, by utilizing the functionalities of TempoGRAPHer, we can spot the higher risk factors for disease spread.